review. We're going to do a Unit 5 review next Tuesday. Okay, we're going to talk about the entire unit. All right, questions before we begin? You can throw it into the chat, or you can speak. Okay. I'm going to minimize that. All right, let's go, shall we? Okay, so Unit 5 is about systems of equations. So that's when you have two lines, two or more, and we're finding where they intersect. Where they intersect is our solution. And so, hi, Katie. The last couple of lessons have been how to do this using graphing and how to find the solution using algebra. The first method of algebra we've done is called substitution. This is with algebra. Today, we're going to talk about another algebraic way to find the solution using elimination. So before we do that, let's review how to do graphing and substitution when we're solving a system. So here's our system. And if you were asked to graph this, now, even if you're still working in Unit 4, you have the skills right now where you can participate. And we are going to graph these two equations on that coordinate grid. So let's see, could someone please verbally share how to do annotate again for those of us that haven't done this in a while?
At the top, there's something that says you are viewing Kim Fergus's screen, and then it says view options, and there's a little arrow that pointing down, and you click on the arrow, and it will say like zoom ratio, hide video, panel, request remote control, and annotate, and you click on annotate, and your options will come up, and there's draw, stamp, arrow, erase, and things. And if you click on format, you can change your color.
Awesome. Okay, so you have to click on format to change your color. Okay, so if you would like to write on the screen today, you are welcome to. Please, good. Katie has claimed turquoise. That's her color. Up in the upper right-hand corner, she wrote her name in turquoise. So we know that any turquoise we see on the screen is Katie's work. Malachi is going to do purple today. And it is totally cool. You participate as much or little as you feel you are prepared to participate today. Because I understand if you're not yet to Unit 5, this might not all make sense. Okay, so just do the best you can. All right. So let's graph. So in order to graph, remind me again, what form of the equation do we need to be in? What form of equation do we need to graph? Best form.
Slope intercept.
We want slope intercept form. That means y equals mx plus b. That means we have y by itself on one side of the equation. So I spy one of our equations is in slope intercept form. Notice number 2 is already has y by itself. For number 1, let's manipulate that one so it is in slope intercept form. And there's a way we can do it. There's a most efficient way. Let's see here. If I subtracted x from both sides, notice that moves the x over to the right side. We're still left with a negative y. That's not slope intercept form. Negative y does us no good because then we have to get rid of that negative. So instead of moving the x over to the right side for that first equation, let's add y and move y to the right side and see what happens here. So negative y plus y goes away. And now we're left with x equals 5 plus y. One more step to get y by itself. Let's subtract 5 from both sides. And look at what we have. Y equals x minus 5. Make sure when you do this that your x is positive and your 5 is negative. Pay attention to your signs there. Okay, so now we're able to see our slope for that line. What is our slope? What is the number in front of our x here? It's a 1. So this is our slope, and -5 is our y-intercept. So we are able to graph our line because we know a point, y-intercept, and then we have our slope, so we can keep finding some more points. So let's graph, what color should we graph equation number 1? Let's see here. Let's graph equation number 1 in orange. Okay. So I'm going to start with y-intercept. It's going to be down at 5. 1, 2, 3, 4, 5. Put in that coordinate pair. And then we're going to use our slope to find some more points. Remember, our slope, we always want to represent as a fraction. So we can see the rise and the run. 1 is equal to 1 over 1 as a fraction, which means I'm going to go up 1 over 1. 1, 2, 3, 4, 5. I have the case of the disappearing coordinate pair again. 1, 2, 3, 4, 5. Okay, so that y-intercept should be right there. Is that showing up on your guys' end, -5? Oh, thank you, Katie. Okay, and then we will use our slope. Awesome, Malachi, you're throwing in some more points. Up 1 over 1 or down 1 over 1 in the opposite direction. Go ahead and put those coordinate pairs in, and then let's use that straight line option under annotate and throw in. Oh, I love the teamwork. Caden, Malachi, beautiful. Beautiful. Okay, so that's equation number 1. Okay, the second equation will be a lot easier to do. Let's see, we did orange for that top one for our final line. Let's do something that we'll be able to see. Royal blue for that second line. Okay, yell at me here. What's my y-intercept? Y equals 7 minus 2x. What's my y-intercept and which of these is the slope?
7.
7 is the y-intercept. Is that a positive 7 or a negative 7?
It's a positive 7, but the slope is negative.
The slope is negative. All right, and our slope, let's write it as a fraction, shall we? So -2 over 1, which means I'm going to go down 1 to the right 1.
Means the line is decreased.
Beautiful. All right, so y-intercept up at 7. 1, 2, 3, 4, 5, 6, 7. Y-intercept means where our graph crosses the y-axis. And then our slope is -2. So we're going to find some more coordinate pairs. Down 2 to the right 1, down 2 to the right 1. Go ahead and decorate that coordinate coordinate graph for us there. Nice. Steeper slope, down 2 over 1. Beautiful. Okay, let's see. If we go down, can we check that line? If we keep going down, our line should be going through, yeah, keep drawing in some coordinate pairs on that line, would you? And let's see where it intersects the orange. I think that the blue line is a little bit off, which is a downfall of using graphing, unfortunately. So notice, I am noticing that if we keep going with that pattern using the slope, they're going to intersect. Yep, beautiful, right there. Okay, what is that coordinate pair where they intersect? Because that is our solution. Sorry, someone's sitting at the table. I'm bumping it here. It's you, son. All right, good. What is that coordinate pair where our two lines intersect? 1, 2, 3, 4. Is it 4? 1, 2, 3, 4, down 1. I think it's over 4 down 1. Go ahead and verify. Anyone else agree with me that it's over 4 down 1 where the two lines intersect? Cool, good correction there. Okay. Okay, so there's our solution. So we know our two lines are going to cross, we think, at 4, -1. Graphically, sometimes doesn't give you a very accurate answer, okay? As we just saw. But anytime you solve with algebra, you will get a very precise answer. So let's now dust off our substitution skills. Might have a little bit of cobwebs from Thanksgiving break. And now let's solve using substitution. We should end up getting the same answer if we do everything right. Okay, so let's write our equations here again. So x minus y equals 5. So in your notes, write down, now we're going to solve this with substitution. Y equals 7 minus 2x. Hey, Seamus, please stop pumping the table. Okay. Oh, we deleted the answer. I'm going to write it in over here. 4, -1. Okay, so substitution, the first step for substitution is to solve one of your equations for one of the variables. So do we have either an equation 1 or 2? Have we isolated a variable somewhere? Meaning, is there a variable alone on one side of an equation?
Yes.
The answer is yes. Which equation? 1 or 2?
2.
Number 2, notice, says y is equal to 7. Nice, Malachi, Katie. 7 minus 2x is equal to y. So this is where the name of the method comes from. We're going to now substitute that value in for y where we see it in the other equation. And now we're going to rewrite our equation. So here we go. We have x minus our y value. Our y value is now 7 minus 2x. And because it has 2 terms, I have to put it in parentheses. Put a star next to that if you didn't do that initially to help yourself remember that importance next time. Okay, here's why parentheses are super important. What do you spy in front of 7 minus 2x? A -1. So in order to simplify this, we're actually going to have to distribute that -1 through to get rid of those parentheses. All right, so let's simplify. We're left with x minus 7 plus 2x equals 5. What we're doing now is we're left with an equation with only one variable, an x. So we're going to be able to figure out what x equals. So use your algebra. Notice on the left side, I can combine like terms. I have a 3x minus 7 equals 5. So the expectation here is that you're doing this on your own paper. This isn't just a spectator sport. You didn't tune in to watch Miss Fergus do math for an hour. You're actually doing it with me. Your brain needs that. Okay, I'm going to add 7 to both sides. 3x equals 12. Divide both sides by 3. X equals 4. Does that jive with what we got with our substitution, or excuse me, with our graphing method? Look at that.
That's what I got.
Yes, good. Our x coordinate, we got 4. Yay, all righty. So now how do we go and find the y? using substitution or using algebra?
We substitute the 4 in for the x.
Beautiful. So you can pick either equation, equation 1 or 2, and we're going to substitute in 4 in for x and figure out what y equals. Notice number 2, the second equation, is probably the easiest one to use here because you can just plug and play. 7 minus 8 equals
-1.
Yay! So were we
Which is
correct?
also what we got on the graph, so it's correct.
Beautiful, beautiful. So the important thing here is that you write your answer as a coordinate pair because your coordinate pair solution where it intersects. So our solution, we got 4, -1. That coordinate pair exists on both of these equations. So we talked about this last week. If you wanted to verify that both of these equations goes through 4, -1, you can substitute 4, -1 into both of your equations and verify that that it works, that it makes both equations true. So last lessons, the Zoom recording is posted in class if you want to watch that one again. It's right under 5.2. All right, questions on this. So this is all review if you are working on PACE. Okay, so now there's another method using algebra called elimination. Let's see what kind of trouble we can get into with elimination. Okay, so with elimination, the main idea, what we're going to be doing is we're going to be manipulating equations again, but we are going to try and get rid of a variable. We're going to try to eliminate a variable. Okay. Main idea is an equation stays blank if you add or subtract the same amount to each side. So if we're balancing an equation stays the same as long as you add or subtract the same value to both sides, okay, which we're going to be doing here, which we have been doing. How it relates to elimination, you can eliminate one of the variable terms in blank by adding or subtracting another equation. Okay, you can eliminate one of the variable terms in an equation by adding or subtracting. So what we're going to do we're now going to solve this equation using elimination. So the very first step is to line up your variables, and you're going to stack your equations, one on top of the other. Notice right now I have X and Y terms are together on the first equation. Second one, they're not. So let's bring over this X term to the left side with addition or subtraction. So we're not changing the value of that equation. So I'm going to add 2x to both sides. Okay, and we now have for equation number 2, I'm going to put the x first because I'm going to match equation 1 with the order. Notice how equation 1 has x first and then y. So I'm going to write equation 2 is now going to be 2x plus y equals -2x. Okay, and then equation 1, I'm going to rewrite it right underneath. Sorry, Katie. Katie, go ahead and draw the line under there, would you? Okay, so we lined up our variables, check, and we just stacked our equations, check, meaning we wrote one on top of the other. So now what we get to do is we get to use addition, subtraction, and we're going to add or subtract the two equations together. And we're going to go straight down. Notice if we added straight down here, 2x plus 1x equals 3x. Our goal here is to eliminate one of the variables. So let's see what happens. What's y minus y or plus y plus negative y here? This goes to
0.
0y. Okay. What did I just do? I made a mistake on the right side there. Why did no one yell at me? Don't you guys like finding teacher mistakes? What should be right there?
Plus 2x.
Ah, good catch, Katie. There should be a 7 there. So I added 2x to the other side. So the 2x is now on the left side. There we go. Okay, 7 plus 5 is 12. Okay, so look what happened. We eliminated our y variable by adding the two equations down. So we added the equations. It eliminated our y variable. And anytime we can get rid of one variable, we can solve an equation in one variable. So we know that x equals 4. Check ourselves, does that jive with what we already know the answer is? Yeah, we know the answer to this system is 4, -1, because we've already done this twice. So we already know the x value is 4 and the y value is -1. So yay. Okay, your last step for elimination is just like your last step in substitution. You need to find your missing variable, and you can do it with either of your original equations. So which original equation would you like to substitute in x equals 4 in?
The first
find
one,
the
because
y.
y is already on one side.
I agree. 2 is probably the most efficient. Okay, so Katie's going to do that work for us. Fingers, toes, legs, arms crossed, we get -1. I have a feeling we will. Okay, yay, we got this the correct answer. So let's do this again now, elimination, and try to get a little bit of fluency. Now keep in mind, if you haven't done this lesson yet, you have a lot of practice problems and some notes to take as well, okay? So this should not make complete sense if this is the first time you've ever seen elimination. So be kind to yourself. Okay, let's talk about when should we use addition and when should we use subtraction. So we talked about that you can either add the two equations up or you could subtract the two equations to eliminate. And so there's a trick here. You're going to want to think mentally ahead. So let's look at this example here. The first example. If I added up these two equations, 2x minus y equals 10 and x minus y equals 3, and I added straight down, does a variable disappear? So I'm left with 3x. No. I have -y minus y. What does that give us?
That would be -2y.
-2y. That does not get rid of anything, does it? Womp womp. Okay. So what this rule is saying is anytime you have an equation where you have the same coefficients, notice we have a -1 on both of those. They are suggesting that you use subtraction.
Because subtracting a negative is the same as adding a positive.
Good. So what we're going to do is we're going to subtract the entire second equation from the first. And remember, when this happens, we have to change the sign for every single term. So I'm going to move this now. This is going to turn into a negative x. This negative y is now going to be a positive y. And don't forget that 3 on the right side. This is a very common mistake that I see with elimination. That negative also has to pertain to that term on the right side. All right, so if your variables have the same coefficients, you are going to use subtraction to eliminate the terms. Same coefficients meaning the numbers in front of a variable. Okay, so right there, see how they're both negative y. Okay, if the variables have the opposite coefficients, oh, why am I yellow? You're going to just use addition. How cool is this one? You just add straight down, hot dog. Notice those y terms go away. So we're left with 4x plus 0y equals 12 here, and that's what we wanted. We wanted to get rid of a y term. So remember, that's your goal with elimination, is to get rid of a term. Okay, so let's see what happens here on the next slide. And this slide right here is actually straight out of your study guide for that lesson. Okay, so let's do these problems together. So notice they're already stacked for us and in the same order. How helpful. Okay, so this first one, let's call it number 1. Let's call the second equation number 2. I also like to number the equations just so it's easier for me when I'm doing my work. I don't lose my place. Okay, so for number 1, notice we have the opposite coefficients. I have a 3x and a minus or a negative 3x. So for this problem, all we have to do is we have to add these up, going straight down. Go ahead, Katie or Malachi, whoever wants to write in what we're going to get when we add those straight up. Okay, so our x terms go away. We're left with a 3y, good, minus 12. Hey, it's very similar to what we got last problem, huh? Divide both sides by 3. All right, y equals 4. Okay, we are halfway done with our solution. We're not done. We have to find the actual coordinate pair. So we just found our y value, so I'm going to substitute it into the y slot. How do we find the y? We're going to substitute it back into one of our original equations.
Let's do the first one because the second one has a negative in it.
Good idea. They both don't, neither of them look very friendly, huh? Why is that? Okay, so this would be 3x plus 6y equals 5. So we want to substitute in 4 for y. So the more practice on these, the better your fluency is going to get. So it's really important that you're doing all the practice problems in these lessons on both the study guide and the checkup. Okay, subtract 24 from both sides. What do we end up getting here? 3x equals, what's that going to be? A negative 19?
Aqueducts.
That seems really weird to me. Is that, yeah, that's right, right? 5 minus 24 is negative 19. Okay, good. All right, so x equals, oh man, it's a dirty fraction. That's okay. Embrace them. Negative 19 thirds. Or you could rewrite it as a mixed number if you want. All right, questions on that one? Okay, so we're gonna get two started. We're not gonna finish it because we need to talk about the other lesson real quick. So for number 2, should we add or subtract these together in order to eliminate one of the variables? And you can mentally add them all, see if a variable goes away. Notice adding doesn't work, so I'm gonna subtract. When I subtract, I have to make sure that I subtract every single term on that bottom equation, which means I'm gonna have to distribute that negative through. So I'm gonna rewrite so I have a minus 4y equals minus 4x minus 7. And notice only then am I able now to add them straight down. Put those down. So we're left with negative y equals negative 2. How do I solve that for y?
You have to divide y by -1.
Good catch. Divide both sides by -1 and we're left with y equals positive 2. Okay, so we just found our y coordinate there. To find your corresponding x coordinate, you're going to substitute that back into one of your equations to figure out what your y equals. Okay, this problem is on your checkup worksheet from this lesson, so you can verify your answer. Finish that up and verify your answer. Okay, so that's elimination. Woohoo, you guys ready to talk about the last lesson? Caden's yawning. Caden. It's okay, Mike.
Okay.
That's why everyone else leaves their screen blank, so I can't tell they're yawning. Okay, let's go. The airport? Oh, I wanted to go through and do one of these things with you. Let's see here. At the beginning of this lesson, of course, my Apex timed out on me. Come on, old Betsy. All right, intermission. Who's providing our music? Okay. So I need to go to there. Okay. Let's see. Can you guys see the screen, the textbook? Okay.
Yes.
Awesome. Okay, so I wanted to do okay, let's go into the study here. I'm unable to help you right now. I don't. I can help you in a little bit. Okay, let's look at this match activity here. So what we're doing now is we're going to be graphing two systems of linear inequalities, and we're going to see where the whole lines intersect, where the shading intersects. In order to do this, you need to be pretty confident in just graphing linear inequalities. So let's match these up to refresh our memory. This was from Unit 4. Which inequality goes with which graph? And why do you think what you think? Now your annotate will work also on this screen here. So notice these are all in a nice slope-intercept form. So you can see the slope and the y-intercept. All right, and let's call that A, B, C. All right, so for A, which graph looks like it goes with inequality A?
The first one. The one that's across it.
Say it again.
The one that's across it. The first graph.
Sorry, Joseph, I didn't hear. Say it again.
On here.
So a y-intercept of 3.
Yes.
What does that less than sign mean right there? Is that going to be a dashed or a solid line?
A dash.
Good. We only have one line here that's dashed, yes?
Yes.
Good, okay. And this is also a less than sign, so we would want to shade all the values less than. Ooh, it looks like it might go with that top one. Should we try it? Oh, yay, it beeped happy at me. Okay, so that matches. All right, so what about B and C? What is the difference here? Both of these are solid lines. One is graphed above and one is graphed below.
If the arrow is pointing to the right, then it's going to be above.
Okay, so this is a less than. So it's going to be shaded below. There we go, good. And this is a greater than. So it's going to be shaded above. Woohoo! All right, let's see. Yay! We're math geniuses. Math geniuses. Okay, so review for graphing linear equations. And so now let's see what happens when we have two of these. So what we're looking for is where both of the solution sets are. Okay, so here's a couple examples of what we're going to see in 5.4. So notice this leftmost one. Oh, there we go. This leftmost one we've got our blue, which is representing all the solutions to our blue line. We've got all the red shading, which is representing all the solutions to the red line. The purple represents the solutions to both of those. And that's what we're looking for here when you're given a system of linear inequalities. So where is the shading overlapped? that is your solution set. So one solution is right here at 4, 0. But that's not the only solution, it's just one. Here's another solution to that system over at 6, 1. Another solution. In fact, we have an infinite amount of solutions because, as we know, these go on forever and ever more. And
wouldn't it be 6, 3?
would it? Oh yeah, wouldn't it be nice to have a math teacher? See, I did that on purpose to make sure you guys were watching. Good, thank you, Katie. Okay, let's look at this rightmost one. Where is the overlapping shading on the right? So your blue line, it's shaded all above. Your red line shaded all below. Are there any solutions that both of those inequalities have in common? Any place where the shading is going to overlap? There's none. So there's no overlap, therefore no solution to that system.
Because they have the same slope.
Okay. So Katie noticed these lines have the same slope. So those two linear equations are never going to intersect, right? And so since the shading is on the opposite side of them, the shading also will never intersect. Good. So your lesson, this lesson talks a little bit about the different scenarios. So just remind yourself you're looking for where does the shading overlap. Okay, so here's the last one we're going to do together. And then I'll stick around for a couple minutes to answer questions. Identify the region containing the solution to the system of equations. So first of all, let's figure out which of these equations is the blue, which one is the red. How can we tell here? Y is greater than or equal to -3x. Notice our y-intercept there is 0. Which one has a y-intercept of 0, the red or the blue? Yeah, good call, Malachi. So our blue line is y is greater than or equal to -3x, which means our red line is y is greater than or equal to 2x minus 5. Okay, so for blue, we want to be shaded greater than the line. So all the values that are greater than the line. So we're going to be shading for blue all the values greater than the line. And we also learned a strategy here. You can substitute in a possible coordinate pair, see if it works, to help a different have a different way to know what side to shade. Okay, so now let's do for the red. We also want to go above. Okay, so y is greater than. So we want to shade above the red line. So here's the above of the red line. Oh yeah, that works, Katie. You could do that for the blue. Okay. Where's the region that those two solution sets overlap? And so typically mathematically what we do is we choose a different color to show where the double overlap is, or where the overlap is. Good, so the pink. So we would say region B is the solution set. Good. So you can have fun with this lesson with highlighters like what Katie's doing. When I graph, sometimes if I only have one color on me, I'll use like pinstripes on one side, and then I'll do dots on another side. Okay. So if you only have one color, you have some options. Just make sure you're showing where the two intersect. You can do a heavy shade for your intersection. Okay, so that's just a quick going over of this lesson. So here's what I would like you to do. If you have questions after you've done the study guide for this lesson, that's when you contact Ms. Fergus, okay? You can email, you can text message me with the Remind app, send me pictures, and then we'll get you set, okay? Do not ever take quizzes, guys, unless you feel confident and that your checkup worksheets are done and you're getting those problems correctly, okay? If you're not getting the correct answers, that's when you contact Ms. Fergus, okay? So reminder, this alone, what we've done today is not enough for you to be ready for the quiz. You actually now need to go through the lesson and practice, okay? Okay, what questions do you guys have? I'm happy to stay in here and answer questions for a few minutes too. Okay, I'm gonna stop the recording here. If anyone's not busy in the next hour and you like to play Among Us, I am hosting an Among Us lunch bunch starting at noon today. If you want to come and play Among Us. Does anyone play Among Us? No?
No.
No? It's fun, try it.
Me.
Who's me? Who's me?
Joseph.
Joseph, come and play. I'll give you, it's in my, hold on, I'll give you the, where's mine? Sticky note that has my personal room number in it. Joseph, I'm gonna put my room number in the chat, okay? 727-940-276. Okay, so there's my personal room.
I'm joining, Beth.
Are you gonna join?
Yeah.
Maybe. So it's for grades 5 through 8. So if you have any siblings in those grades, bring them too, okay? Well, maybe if enough people like to play Among Us together, this can be a weekly thing. So, okay. You guys have a good week, and I am looking forward to you contacting me with questions. Yes?
Yeah.
Okay. Bye, guys.
Bye. Thank
You too, Malachi.
you.
Bye.
See you next week.
See you next week. Bye, Kaden. Hey, Kaden, you're working hard. You're getting caught up in Apex, yes?
Yes.
You're gonna send me.
Yes.
And
Well, goodbye.
Goodbye. If you have questions, you're going to
I want to.
Email you.
send them to me. Good.
Yeah.
Okay. See you later.
I wanted to ask if I am on OP or DP or.
Where are you right now, Joseph? Are you?
Well, I haven't done the 5.3 or 5.4 yet, but.
I think you finished unit 4, right?
Yeah.
Yeah. So I'm pretty sure you're OP.
Okay.
Yeah, I'm almost positive. Yep. Good.
Just wanted to double check.
Yeah. So by the end of next week, you want to be completely done with unit 5. Okay.
Okay.
And don't take your unit 5 like final test and stuff until after next Tuesday, because we're going to do a unit 5 review.
Okay.
Sound good?
Yes.
Okay.
Have a good day.
Okay, you too. Bye.